Many of you will be getting to the stage where you want to start CADing up your gearbox for your mechanism design. I just thought I'd take you through some of the dialog boxes in the design accelerators that will help you to do that fairly easily. So I've produced this worm gear here. If I right click and edit using the design accelerator, you can see how I've done it. I've specified that I want 56 teeth on the worm gear, and that I want a tan module of 2. I can preview everything as I go if I need to, and basically that's it. There's nothing else you need to know, apart from the fact that you've got the option here to produce no model, which might sound daft, but if you've got some existing components that you want to make use of, you can produce a component from one of those and vice versa. So you can choose one of these not to produce a model, so either the worm or the worm gear, if that makes sense. Okay, and that will generate components and put them into the design center for you. Okay. The other thing that I wanted to show you was the spur gear generator. So spur gears work in a similar way. You've got the option again to either produce the component, to use an existing feature, or to produce no model at all. So if I just want to produce one spur gear, but to have it reliant upon another gear, but I don't want to produce the model for that, for example, so I just want to produce one gear, I can produce that by specifying the teeth here, 36 teeth here, 24 on this one. It'll calculate the center distance for me already, which is nice. And I make sure there's no unit correction value in here either, because that will kind of mess things up. You've got previews of exactly how the whole thing works. It'll even show you how the teeth mesh, and you can animate them as well. It's got a lot of quite useful features. A very useful one also is this one here. If I press calculate, you can press this button here and it will give you a complete printout of all the pressure angles, the torque being applied, which might be useful for your report as well. You can do that by going into your calculation tab and specifying your power speed ratios and what have you here, and that will give you quite a lot of information that you can include in your report if you feel you need to. Okay, so I'll quickly take you through how I produce spur gears that actually interact with each other. I've made a little base plate here with a couple of pins sticking up. It is there. Okay, and I've put a couple of little washers around it as spacers. And all I've done is I've used the design accelerator to produce these two components. I've done them separately, so if I edit using design accelerator, you can see that this component here was done using this one. So I've asked gear 2 to be made as a component, but for no model to be created with gear 1, even though I've used a 20mm face width, I've used 24 teeth and 36 teeth. This is obviously the one with the 36 teeth, and that's the gear ratio. So I click OK and it generates the component and puts it in here, and I do the same with this one, and only this time obviously I've got it to create the component with the 24 teeth here, and this one has produced no model. Now the reason I've brought those in separately is that it means that they are then able to interact with each other more successfully. I'm probably missing a trick somewhere, but it seems to me much easier if you bring them in separately. I've then put in these rotational constraints here. They're joints actually, not constraints, in order to make sure that they are free to rotate. And then I've put a rotation, a motion constraint on the motion of these two together. So when I move them now, they interact with each other correctly. And what I've done is, once I've created this constraint, I've actually gone in and I've suppressed it. I can then move this one so that it's correctly aligned, as close as I can anyway, and then I can then unsuppress this one, and then it'll interact correctly. Okay, so that's how I've done that. Let me just show you how you create that interaction. And these interactions will only work if both components know where they are in space and are constrained correctly within the assembly. They need to be able to use the reaction forces correctly. So if I go into edit, I can edit that constraint. So I've basically gone into the motion tab here on the constraint. I've chosen angular contact. I've chosen for them to go in opposite directions, obviously, and I've taken this value here as 0.6667. That is the ratio of the speeds. Now, the reason I've taken that value and put that in manually rather than the value that was given to me is because when you select these two faces, so I selected that face there and I selected that face there, and when they have slightly different diameters to the ones that were specified when the spur tooth was made, and that's because there is obviously a gap down in here. So that's why you must specify the speed ratio rather than the diameter ratios. So put that in there, click OK, and you should then be able to get these to interact with each other. If you click at the very bottom of the model tree, you can go to Place from Content Center. And I've already had these open. You can go to Circlips, Fasteners Circlips, External Circlips. I'm going to go to this one here. Click OK, and then it will ask me for a reference. And it will ask me for another reference here. Auto drop. Click OK. It should fit them both for me. Okay, so this is the start of an epicyclic gearbox, which looks tricky, but it's actually quite simple if you use the spur gear generator. In fact, all the motion constraints are working on this one. You can see there's 96 teeth on the ring gear, the outer gear. The planet gear that I'm moving now has got 36 teeth, and this is 24 teeth. This is the sun gear. And the drive is coming through the sun gear, through these into the outer, and that is giving me a 5:1 ratio. So I've produced these. If I right click and edit using Design Accelerator, you can see how these were produced. I've literally just specified that I want 24 teeth on the sun gear. I'm asking it to produce the component. The second gear, if I put this in as 36, calculate, that should come down to, put that as 0, that should come down to 30mm center distance. And I then am able to make sure that it doesn't produce a model for the second component, it's only producing the sun gear on its own. So I click calculate and OK, accept, and it will produce the sun gear for me. Okay, do the same with these, and if I open up the relationships folder, you'll see that I've got a 30mm relationship between those two, 30mm between those two, and 30 between those two. They can be a real pain to set up. They jump on top of each other, and then you have to separate them again, and sometimes they flip. You'll just have to be patient with it. You've also got flush mates on them here, so that we know that the surface of them is all flush with each other. The other thing that I've done is I've produced what I call a spider, which is this casing here, and it's got 3 prongs coming off the centre of that spider, and they have got rotational constraints on them here. Sorry, these here are the rotational constraints, and these are the motion constraints that control the speed at which they rotate. That allows me to turn any of these and they will all interact correctly. You don't need to go to this level of detail. I'm simply showing you what's possible. The reason I've made this casing deep, and I should probably go a bit deeper with it, is that I'm planning on having a secondary step down, so that I then take my drive off here. So this becomes the driven component, and then I take my output off these 3 points here using another spider or a faceplate, and that will allow me to go from 5 to 1 and then from 2 to 1 back down again, because the centre point of this is always travelling at half the speed of the outer. But it's all fairly straightforward. If I show you the ring gear, all I've done is I've clicked the internal option there. I've told it I want 96 teeth there. This one should have 36. It'll calculate the centre distance for me. I don't want that. Go back to 30. And that should be correct. Okay, so I'm hoping that will get you through most of this piece of coursework. Just remember that we don't require huge levels of detail. This is an opportunity for you to demonstrate that you know how to model these components, and get some rough calculations done to hand off to the next design phase, the detailed design phase, to take the gearbox to the next level. I'm doing this with a very heavy chest infection at the moment, so apologies if it's not up to the usual standard. But give me a shout if you need any help, and I can hopefully answer questions by email. Cheers.